welcome to Solidworks Station. My name's Stuart, and in today's tutorial we're going to talk about this exam question in preparation for the CSWA Mechanical Design Examination. This question is based around part modelling. If by the end of this tutorial you feel that you're struggling with some of the content, or you feel you need some more support or guidance around what I've spoken about, then please get in touch and I'll be more than happy to help you out. Just drop a comment in the comment section below this video and I will be sure to reply. Best of luck, and let's get started. Okay, so the first thing I want to do is go into SolidWorks, and I'm going to do File, New and Part. I'm going to go into my tools and my equations, and I'm just going to put in my A value as being 81. Press the tab key to come across. My B value is going to be 57, and then my C value is going to be 43. And I'm going to press the OK button. Once I've got these global variables in, and I've checked the evaluate to the correct value, it's fine to press the OK button. So from here, what I'm going to do, I'm going to go into my front plane, I'm going to go normal 2, and I'm going to produce a sketch of a rectangle that I'm going to associate the A and B value with. I'm going to make this for construction, and I'm going to place in the circle of 14mm diameter on my origin point. Let's smart dimension this up then. So I know that this is 14, and I know that it sits 14mm from this edge, and if I calculate the 14 here plus the 19, it's 33mm away from this bottom edge. So from here to this bottom edge, I want this circle to be 33mm away. I can give this a smart dimension now. If I press the equals button and go to global variables, that's going to be A, and smart dimension this one. Press the equals button on the keyboard, global variables, and this is going to be B. From here, I'm just going to trace out a rough outline of what this sketch looks like. So I'm going to start about here. I'm just going to be careful not to get any relationships here, so I don't want to get relationships like this involved. Just stay clear of those. So I'm going to go up to about here and across. Horizontal relationships are fine. This is coming down at 10 degrees. And if I go back to this line, I get my arc. This is going right up to the top. Then I'm going across and diagonally down. Straight line down here. Just careful not to get any relationships involved again. And I'm going to stop there. And I'm going to come back over to this side. Going to drop a line down here. Okay, like so. Just going to drag some of these lines about just to get this looking a little bit closer to what we've got. So I'm going to move this line up a little bit. I'm going to move this one across a little bit. Okay, something like that is fine. Okay, let's get around this now clockwise, and let's smart dimension this up. So the first thing I'm going to do is smart dimension this line up at 45, and then I've got from here to here, this is going to be 7. So there's my 45, there's my 7. Let's zoom in on that for you. Okay, so there's my 7, there's my 45. I'm going to put in this 14, this 10, and this radius of 19 next. So I've got from here to here, at 14. I've got an angle here of 10 degrees. Got a radius here of 19. Okay, zoom in again. So I've done my 7, 45, 14, 10. It's saying that this is tangent to this line here, so I'm going to check that, and I've got a 29, 45 and a 5. So my 29 can go in there. This is a 45 degree line. And this is 5 millimeters. I just want to check that this is tangent to this line. So I'm going to click on this line, and just make those tangent. Okay, moving down, I've got 24 to this point. To the top edge is 24. I've got this at 29. Okay, that's crossed over there, that's not a problem. I can just move that back over, like so. Okay, I've got a radius here of 5. And I've got a radius here of 29. However, that 29, if we just zoom in, is taking 19 millimeters up from this bottom edge. So we need to make this point here and this point here, holding down control, make those coincident, and then give this a distance from this bottom edge here of 19. Like so. Okay, we've got a height of 19 to this underside. So from here to here is 19. This angle here is 45 degrees. And the distance between this point here and this point here is 7. We're getting close to being fully defined. There's a few things here that are missing. I'm just going to smarten these dimensions up just so I can see everything nice and clearly. Just a good idea just to keep it nice and smart, especially if you're doing the exam, just to keep everything nice and tidy, just so you can read everything and double check all your calculations are right. Okay, so let's just check our drawing, let's see what we're missing. This 14 we did at the start, this 14 we did at the start, we did this 33, we've got this in, these are tangent, this 32 we've not got, so let's put this 32 in. That should resolve quite a bit actually, from here to here, 32. Fully defined, perfect. Okay, we can move on to the next step. Okay, so now we've got all the smart dimensions in and we are fully defined in our sketch. We know that because it says fully defined down here and all our lines have turned black. Anywhere on your model, if there's any blue lines, that means that that line has still got the ability to move and it's not fixed in space with a set of dimensions. So just be careful of that. Just make sure you've got all black lines on your screens before you extrude this. So I'm going to go into Features, Extrude Boss Base, And here where I've got D1, we know from our engineering drawing that we're going to extrude this by C, which we've got set up as a global variable. So I can go into here, I can press the equal sign, go to global variables and go to C. For some reason it doesn't update in here in SolidWorks, so just be careful, make sure that you've got C in there. You've not just typed C, you've picked it from the global variable selection list, and then you're going to click on the green tick. You can be sure that you've got the correct global variable in just by going to the Evaluate tab, go to Measure, and just click on one of these lines and just ensure that you've got 43 in there, which was for C. From here we need to assign a material which is specified as being AISI 1020 steel. So if we go into our materials, right click and edit the material, and we're looking for steels 1020. There we go, and it's got to have a density of 0.0079 grams. Okay, which it would do if this was in grams per millimeters cubed. So we're going to apply and close, and then from here it's asking what is the overall mass of the part in grams. Really easy, this one. Okay, we're going to go to the Evaluate tab, Mass Property, and there it is, the mass of that in grams, 939.54 grams. If it asks for this in kilograms, okay, you could go up to Options, you could change all this to use custom settings, and you could have mass in pounds, kilograms, milligrams, okay, per meters, per nanometers. Your decimal places is here where you change that. It's asking us to do it in to 2 decimal places, which we've got selected here, so that's all fine. So grams and millimeters. So there's your answer, 939.54 grams. Okay, that concludes this tutorial on the CSWA practice examination. If you struggled with anything during that, please do get in touch. I'll be more than happy to give you some advice and support around it and ensure that you are able to complete this particular model. Join me again for another SolidWorks Station tutorial. Please don't forget to like and subscribe, and if you're new to the channel and you're enjoying the content, then don't forget you can always give a big thumbs up. Thank you very much, and see you all soon.